Okay, so we have been talking about all these different kinds of inequalities. You know how to solve an inequality, right? Just like an equal sign. Only, what's the big exception? If you multiply or divide both sides by negative numbers, you have to flip the inequality sign, right? You know that. You know compound inequalities when you have two different things. X is greater than this and X is less than that, or X is greater than this or X is less than that. You know how to do those. You know how to do graph inequalities with two variables. Now that's what we're going to continue with, right? That's what you did this last night on the homework, and I was really impressed. You guys really got it down beautifully. So this is the next step. And I've actually never taught this early in the game before. Usually I teach systems of equations first. I've never taught systems of inequalities first. But you guys are so good at them that I'm okay with it. Like, it'll be fine. And systems of inequalities. First of all, you guys know what an inequality is. An inequality would be something like y is equal to x. Let me just think of one. X plus 2, and okay. So that's an inequality. Excuse me, not an inequality. That was an equation. Now it's an inequality, right? So that is one inequality. When you talk about a system, in math we use the word system to mean many. For example, like stereo system, right? What is that made up of?
Stereo, mostly radio, or most of the time radio.
Stereo,
speakers.
radio, speakers. You gotta have wires, cords.
Trebles,
balances, right? You've got to have, you know, woofer.
What's a woofer?
Woofer.
A
Right?
woofer
Really
is
low.
this.
Right? You guys know woofers? Don't you know woofers?
Oh, and then there's plenty of chips
And then
inside.
a tweeter.
And there's plenty of computer chips inside.
And yeah, there's like, would you agree with me that a stereo system is more than one thing?
Yeah.
So a system, a mathematical system is the same thing. It's more than one thing. So instead of having one inequality, I'm going to give you more than one inequality. I could give you an infinite number, right? A system could have an infinite number of inequalities, or it could have just two inequalities, or three inequalities. We're going to be focusing on just two, okay? Because it's just easier, right? It's like no sense to make it too hard right now. So let's say I had that one, and I had, we'll just use this one. Y is less than negative x plus 3. All right. And let's just think about that for a second.
Wait, Gary?
Yes.
Can you have a negative variable?
Yeah.
No,
Yes.
I mean like at the end of the problem.
Well, yeah. If it said negative x is greater than 2, for example, right? Then you can't leave it like that, because you don't want to know what negative x is, just like you don't want to know what 6x is or what negative 5x is. You want to divide by negative 1. Negative x, divide both sides by negative 1, then you get positive x, right? And then that sign flips, right? Because you divided by negative 1, and then whatever your other number is, right? Does that make sense? Don't ever leave your answer with a negative x. Basically, well, yeah, you got that. So sometimes you're going to see. I'm going to graph it in a few minutes, but before that, I want to ask a question. So this is a kind of question that you might get. Tell whether the ordered pair is a solution of the given system. Is a solution of the given system. So this is how you'll see it. You'll see something like this. You'll have 0, 0, and then you'll have a semicolon usually, and then you'll have this brace, and you'll have y is less than negative x plus 3, and y is less than x plus 2. Basically those, right? So that's the kind of question you're going to get a lot of times with these. And what is an ordered pair? Anybody know what that is? An ordered pair. Yes, Ben. I mean, Gideon, sorry.
An ordered pair is a pair of numbers in a parentheses, or in a parenthesis. They're surrounded by parentheses,
right.
And then you put them onto a graph.
Right, on a coordinate plane, right? So the first thing is your x, and the second thing is your y. And so it tells you to go nowhere to the right or left, and it tells you go nowhere up and down. So your x is 0 and your y is 0. So it says, tell whether the ordered pair is a solution to the system. How would you do that? What would you do? This solution, these two systems, or this system, these two inequalities have y's and x's. But did they give me y's and x's?
Sort of.
Where?
In the
Ordered
pair.
This is an x, right? The first one, comma, y. That's a y. So you're saying x is 0 and y is 0, right? We want to see if that gives a true statement, right? So let's try it. So I'm going to substitute it in here. 0 is less than negative 0 is just 0. So I don't even have to write it, plus 3. Is that true? Is 0 less than 3?
Yes.
So that's true. So can I say, yes, it's a solution to the system?
Yeah,
Not yet. Why?
because there's still another
There's still another part of the system. I have to check that one out. So I got to do 0 again. Is less than, that's 0. I don't need to write it because it's nothing. And then 2. Is 0 less than 2? So yes, it's true. Therefore, yes. The answer is yes. It is a solution, right? 0, 0 is a solution. 0, 0 is a solution.
Gary?
Right? Whoops. Exclamation point. Whatever. Yeah.
Remember I said?
Yes.
Okay, so for the first one, y is less than negative x plus 3. You would subtract by 3, right?
No. No. Because that's only negative x. It doesn't have anything to do with the 3.
Okay.
It's not, if it was in parentheses, then you'd have to distribute it to the 3. But that negative only means minus x.
So
And if x is 0, it's minus nothing.
Just 0.
Right. So we're going to take nothing away, and then we're going to add 3.
Okay,
Does that
thank
make
you.
sense? Yeah, good question. All right, you get the picture?
Yeah, sure. Sure,
done?
that's fine.
All right, so I'm going to ask another one. Is, let me think, let's try this. Is 4 comma negative 8 a solution? So now we're going to erase this. We're going to come back over here, and we're going to plug those in. So negative 8 is less than negative 4 plus 3. So that would mean negative 8 is less than negative 1. Is that true or false? That's true. Okay, that one works for sure. Okay, good. Now let's try this one. Negative 8 is less than 4 plus 2. 4 plus 2. Is that true? So negative 8 is less than 6. That's also true. So yes, that's also a solution to the system. Okay?
So,
Right? But now let's see if I can do one that doesn't.
So Gary,
Yes. Yes.
the answer in the box would be true. Right? True.
Oh, what? I'm sorry? Say it
In the
again.
end, like, if you were to box the answer, it would be true. You would box.
Yeah, I would say yes solution, basically, right? Okay, let's say it worked out that this one was true and this one was false, even though it isn't, right? But let's say it was, right? And this one turned out to be false. Then it is not a solution to the system. It's a solution to the first one, but not the second one. Therefore, the system is both, right? It's the whole thing combined. So it's not a solution if one of them is false. If both of them are false, it's obviously also not a solution, right? Does that make sense? Fist to 5, do you understand these? Not really? What's the question? I see a question in my face.
So, like, I don't really understand what the point of this is because, or like, I don't understand what true means or anything.
Oh,
If you
well,
look at it.
is -8 less than -1?
Yeah.
That's true then. That's a true
Okay.
statement. If I had said is -8 greater than -1, would that be true or false?
That would be false.
Right. See, that's what I could have done. Let's say I changed this one to this, right? And then this second one I said -8 is greater than 4 plus 2. So -8 is greater than 6. Is that true or false? You agree with me? For sure? That's false. Therefore, that is not a solution to this system the way I just changed this inequality. Right? All right. So that's that. Now, so you'll see a few of those on the homework. But most of what you're going to see on the homework is graphing. Well, actually, yeah, we did take a picture. Let me just think for a second. Why don't I, that's fine. We'll just do this. Y, I'll keep it as what it was. Y is less than -x plus 3, right? So I'm going to graph that. So I am going to use 2 different colors, and I would recommend you guys do the same thing. It's really more fun to do 2 different colors. But so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay. I'm going to use, if this works, green. I hope that shows up on the camera. And I'm going to use orange. Hopefully that shows up on the camera. So I'm going to make this one in green. Is that seeable? Not really. Does this work? Okay. I'm going to use blue for this one. Okay? And we'll do that one first. So how do I graph it? Up from 0, 0. That's my y-intercept. I go up 2. Put a dot. Right? And then my slope is what? 1 over 1. Rise 1, run 1. So I'm going to rise 1, run 1. Right?
Yeah.
Right? And then now I could rise 1 and run 1 again if I want. And now I see I've got a nice straight line. So is it going to be a solid or dashed line? So I'm going to do a dashed line. Okay. Now I'm going to decide whether 0, 0. I have to shade. Because it's a less than, I've got to shade everything on this side or everything on this side. And that would be my solution, right? Right? So which way would I shade it?
You would shade the bottom side.
0 is less than 2. Is that true? 0 is less than 2. 0 is less than 2. Therefore, this is a solution. Right?
So
Do you
then
see what I did there? So I have, that means everything on this side is a solution. Everything.
So then that
Right?
kind of
This is called my, what kind of line is that called again?
Boundary line.
My boundary line, right, exactly. So I'm going to be shading everything this way. All right?
So we're just graphing a system.
We're graphing a system of inequalities, right? So I'm just kind of going all the way because I want you to see the end result, right? And you'll see what I mean. And then if I have time, I'll show you a shortcut, but I don't know if I will for shading. Okay, so everybody, that's pretty straightforward, right? Fist to 5. You guys all know this, right? Pretty easy, right? So now we're going to use orange. Orange is going to be for this one. Okay, so it says I do 3. So my y-intercept is 3. I go 1, 2, 3, put a dot. Right? I'm making my orange black. Okay.
Down 1 over 1.
So yeah, it's down 1 over 1 because it's a negative. So I go down 1 over 1, put a dot. Down 1 over 1, put a dot. And that's a straight line. Is it going to be solid or dashed?
Dashed.
Again, it's going to be dashed. So it's going to look like this. Right? All right. And then now I have to shade it. Now I got to try my 0, 0 again. Is 0 less than 3? Is 0 less than 3? It is. So I got to shade towards 0, 0, right? Now, look at this. See how these are crisscrossing? The shading, wherever you have that crisscross, is part of the solution to the system. It's sort of like the and problems, right?
So then would you
It's
erase the
this
other stuff?
and this, right?
Then would you erase the other stuff?
So, say what?
Then would you erase all the other stuff?
You don't have to erase it, but you know what I'm going to do is I'm actually, where's my line? I am not going to go anywhere past it. Because as soon as I get over here, do you see there's not going to be any crisscrossing?
Yeah.
I'm not going to bother shading that. Because I care, this is what I care about, is the solution where the crisscross is. I didn't even need to shade this up here. I just needed this so I can see this beautiful thing, and it goes on forever and ever. Right? Does that make sense?
With them crossing.
Could we do colors on our homework here?
And yeah, I would recommend you do colors in your homework because it's just more fun and it'll be much clearer. Does that make sense?
So do we use colored pencils for homework?
So use colored pencils for homework.
Can I use
It's
pens?
it's like kindergarten again.
Yeah, just that if you mess up, it's harder to erase it.
I don't have erasable colored pencils, so
Okay.
it's
Can I
good.
use pastels?
All right. So, okay, guys, listen up for 1 second. If you keep going, it just makes it harder to see the final solution. But if I asked you for this graph, for this systems of inequalities, okay, Lila, if I asked you this question, I want you to give me an answer. Give me 3 solutions to this inequality.
0, 0,
Negative 1, positive 1.
No, okay. Positive 1, negative 1.
Positive 1, negative 1.
And
Positive 2, negative 2. Anything in this section would be a solution, right? So if I asked you to give me 5 points, you would just find points in the shaded in the doubly cross-hatched shaded section, right? So that's good. Awesome. So that's it. That's the lecture.
Thank
And
you, Gary.
you're welcome.